This is an introduction to oscillations. An oscillation is a repetitive and regular movement about a fixed point, and that fixed point is referred to the equilibrium position or the rest position when the object is at rest, and the repetitive and regular movement is a to and fro motion about that fixed point. The distance the object is from the equilibrium position is known as displacement, with the amplitude representing the maximum displacement. The period of an oscillation is the time taken for one complete oscillation, whereas frequency of an oscillation is the number of oscillations that occur per unit time. From the definition of period, we have one oscillation in t seconds. So that means 1 over t oscillations occur per second. Frequency is the number of oscillations per second, so 1 divided by the time period equals the frequency. Phase is the fraction of the oscillation cycle that has been completed, and this fraction is expressed as an angle, which is measured in the units of radians. For one complete oscillation, the phase will equal 2 pi radians, which is equal to 360 degrees. And the graph of the displacement of an oscillating object plotted against the phase will look like this. So for a complete oscillation, the phase is 2 pi. For half an oscillation, the phase is pi, 180 degrees. And for quarter of an oscillation, the phase is pi divided by 2 radians, which is 90 degrees. Phase difference between two oscillations looks at how out of step the oscillations are. If the two oscillations are in step, then we say they are in phase, and their displacement time graphs will look like this. So they're both at the same time, they're both at maximum positive displacement and at maximum negative displacements. So the phase difference is equal to 0. If the two oscillations are out of step by half a cycle or half an oscillation, we say they are in antiphase. And we can represent the displacement time graphs of these two oscillations as this, where the time when one oscillation has maximum positive displacement, the other oscillation will have maximum negative displacement. And as they're out of step by half a cycle represents in phase pi radians. So we say their phase difference is pi radians or 180 degrees. Angular frequency is the rate of change of phase, or the change of phase per unit time. And we know for one complete oscillation, the phase equals 2 pi, and the time taken is equal to 1 time period. So the angular frequency, denoted by the symbol omega, is equal to the change in phase, which is 2 pi, divided by the time taken, which is the time period. The units of angular frequency is then the units of phase, which is in radians, divided by the units of the time period, which is seconds. So the units are radians per second. Also, we know 1 divided by the time period equals our frequency. So the angular frequency is also equal to 2 pi f.